Hi everyone, just a follow up there on indices, some more rules for you. If you were given something like this, 5 squared to the power of 3, so that's a number that's already in index form to the power of another number, or power to a power. Well, what do you do there? That's 5 squared multiplied by 5 squared multiplied by 5 squared. That's what to the power of 3 means. Okay, so you take this, you multiply it by itself 3 times. Well, what's that? That's 5 by 5 times 5 by 5 times 5 by 5. Okay, so you get 5 multiplied by itself 6 times. You can probably spot the rule. You multiply 2 by 3, that gets you 6. Okay, and you can kind of see there's 3 sets of 2 5s, so it makes sense that there'd be 6 of them in the end. If you look at page 21 on your log tables, you'll see this rule written as a to the power of p to the power of q. And you can probably write down what that is if you want to give it a go. Hopefully, you've just written down a to the power of pq, or p multiplied by q, okay, which you can just write as pq. Okay, you might try these ones yourselves. Pause the video there and try those 4 questions, see how you do. These last 2 are a bit tricky. Okay, so hopefully you've said 4 to the power of 3 to the power of 5. Well, that's 4 to the power of 3 multiplied by 5, or 4 to the power of 15. 2 to the power of 8 multiplied by 3. Hopefully you've said that's 2 to the power of 8 multiplied by 3. And that's 2 to the power of 24. I'm not going to work these out, by the way. You could go to your calculator if you wanted to, but these are actually both very big numbers. 2 squared to the power of minus 2. Now that minus might throw you a little bit, but the rules are just multiply 2 to the power of 2 times negative 2. And 2 times negative 2 is negative 4. So it's 2 to the power of negative 4, or if you wanted to write it as 1 over 2 to the power of 4, that'd be fine as well. Or 1 over 16, because that one's easy enough to do in your head, you can work it out. Either of these 3 answers would all be acceptable. Okay, they all mean the same thing. And down here, same thing, you might get thrown by the negative indices, but 2 to the power of minus 3 by minus 2. And a negative times a negative gives a positive, so that's 2 to the power of 6. What's that? 16, 32, 64. If you wanted to work it out, which again, you can leave it like this, and that's fine. Second rule that I want to look at today is this one here. 2 multiplied by 3 to the power of 4. Okay, well, what's that? That's 2 by 3 multiplied by 2 by 3 multiplied by 2 by 3 multiplied by 2 by 3. Okay, 4 times. 1, 2, 3, 4. Well, that's the same as 2 multiplied by 2 multiplied by 2 multiplied by 2. That's 2 to the power of 4 multiplied by 3 multiplied by 3 multiplied by 3 multiplied by 3, 3 to the power of 4. Okay, so that's just saying that when you have multiplication, the index outside can be applied to both of the numbers you're multiplying. Okay, so what we say here is that the index is distributive over multiplication. I'll discuss that again in just a second. Down here over division, 2 divided by 3, or 2/3 to the power of 4, you get the same thing, 2/3 by 2/3 by 2/3 by 2/3, because there's 4 of them. Well, that's 2 by 2 by 2 by 2. That's 2 to the power of 4 from the top, and on the bottom, 3 by 3 by 3 by 3 is 3 to the power of 4. Okay, and if you want, you could work that out. You're going to get 16 over 81, or you can leave it like this. The point I want to illustrate is just that the index can be applied to top and bottom of the fraction. So again, we see that the index is distributive. I'll just write that word down. Distributive over multiplication and over division. So again, on page 21 in your log tables, you've got these 2 rules. See if you can write out the following bit. Just pause the video, see if you can write that out. Okay, hopefully what you wrote was a to the power of p over b to the power of p. You've given that p to both the top and bottom of the fraction. You've distributed it. And here you've said a to the power of p multiplied by b to the power of p. So you've given that p to both parts of the multiplication. Okay, so you might try these 3 here. Pause the video there. Right, hopefully you have said that is 2 cubed multiplied by 6 cubed. Okay, if you want to go and work that out further, you can, but that's all I'm interested in is, do you know that that's how it works out? Okay, the three distributes. Here, that's 2 cubed multiplied by x cubed. And you'd probably tidy that up because 2 cubed is easy enough. That's 8x cubed. And here, hopefully it said 6 squared over 3 squared. And that's easy to work out at 36 over 9. And 36 goes into, or 9 goes into 36 4 times. Now I picked an easy one there because if you come back over here, 6 over 3 is just 2. So that's 2 squared. Well, 2 squared you can see is 4. So that's come out right. And you know it's come out right. Now I'm going to ask you to go now and do page 237, question 10, please. See how you get on, correct it at the back when you're finished. Tomorrow we're going to finish that exercise on page 237, 238. Just one final note about this idea of something being distributive. So indices, like this square here, are distributive over multiplication. 4 times 3, that's 12 squared, is the same as 4 squared is 16 multiplied by 3 squared is 9. Okay, now 12 squared, 12 by 12 is 144, and 16 multiplied by 9 is 144. So you can see that that works. Both sides of this equation say 144 in some different form. If I try and apply that rule to addition, well, what I get here would be 4 squared plus 3 squared. That's distributing my square over addition. But look what I've got. 7 squared is the same as 16 plus 9. Is that true? Well, that's 49 is the same as 25. No. So that's not true. So these indices, they're distributive over multiplication, but not addition. Similarly, they're distributive over division, but not over subtraction. Okay? That's a minor point. Really, I just want to use that word. I want you to hear that word. Go and try question 10 there, and I'll see you tomorrow.